term?
1.
Really? What's the next term?
Yeah.
2x over?
Oh, what? 2x?
10.
10.
Plus, what's the next one?
3x cubed over
3x.
3x cubed.
Squared.
Squared.
All over?
100.
Okay, AJ.
Why is it a power series?
Each term.
It's not a geo, it doesn't have to have a common ratio, but it is a power series because I have x to the, x to the, x to the, x to the. It's a power series. Okay, why? This shows all the powers of x.
Miss T,
Yeah.
can you have to write the commas in the thousands for AP exams?
No.
Okay.
Just don't go writing decimals. On that today. Meaning they would see that the thousands to me, but then if you accidentally did a stray mark that looked like a decimal, they wouldn't know it was a thousands to you. Alright, letter B, using the ratio test. What did you guys see with the ratio test as to when a sub n plus 1 all over a sub n converges? Is it a less than? Is it a greater than? When does the ratio test show convergence? What is the limit as n goes to infinity of the n plus first over the n? Less than 1. Good. So how can I use the ratio test to consider convergence? Well, can't I take the limit as n goes to infinity of the n plus first? So question, first of all of these are positive. Do I need the absolute value?
No.
Okay, good. Throw that out. But what's the n plus first term? N plus 2, because it's n plus 1, times x to the n plus 1 all over 10 to the n plus 1 times, okay, ratio test, hold on, when you divide by the n, isn't it multiplication of the reciprocal?
Yes.
Okay, so I have the n plus 1, I have the x to the n, I have the 10 to the n, ooh, less than 1. When or where or for what values of x this is truly less than 1, the ratio test will prove the convergence of the power series. Can we reduce some stuff?
Yeah.
I think so. Because doesn't the 10 to the n over the 10 to the n plus 1 end up just being 110?
Wait, yeah.
Doesn't the x to the n plus 1 all over the x to the n and just end up just being x? And then don't you just get n plus 2 over n plus 1? Question, who is going to infinity? What is going to infinity? N. Question, just looking at the n's, what's the ratio? Yeah. Ratio of the leading coefficients because the degrees are tied, just 1. So what do I have? Well, technically, okay, hold on, wait a minute. All of these terms were positive, but can't x be a positive or a negative? Okay, wait a minute. So what if we needed to throw those in? What if we know that this is always positive, but we don't know what's going on with the x? So what would we need to do in order to solve x over 10 needs to be less than 1 because the limit of this guy is 1. The limit goes away. How do I finish figuring out for what x's this will work? Guess what? You just found your first interval of convergence of a non-geometric series. The ratio test tells me when the ratio proves for me, given a ratio, when or where a series will converge. So even though up until this point we've basically just been using the ratio test to go forward to convergence in chapter 9 OT, now we can take a series and we can go backwards and say not just that it converges, but where it converges or in what interval it converges using the ratio test. Because x is this additional variable that is apart from the n's. I can take the limit of the n component for the n pieces, and I can have this x remaining, and then I can go ahead and just solve algebraically. And for those of you guys who are like, how did you? Remember, I went ahead and followed Kevin's advice, which was multiply both sides by 10, because 10 is not bound by the absolute value. The absolute value of a positive is a positive. Multiply that on the other side, and remember, the absolute value says, ooh, got to consider the positive and the negative. Positive 10, x will be less than, and then negative 10, flip the inequality, x will be greater than. So maybe that endeavor card that you wrote down yesterday from section 10.4/5 about the interval of convergence. Having an a sub n plus 1 over a sub n makes a little bit more sense in that we're really just applying the ratio test. We apply the ratio test in order to figure out intervals of convergence of non-geometric. Wait, why am I saying non-geometric series? Or non-geometric power series? Geometric says interval of convergence will be when the common ratio less than 1, or in between -1 and 1. So I can find interval of convergence for geo, easy. But for anyone who's not geo, wait, why isn't this geo? Isn't it times x over 10, x over 10, x over 10, x over 10? Oh. The 2, 3, 4 doesn't work for geo, does it?
No.
Now, what was my hint when it came to letter C? Did any of you guys get stuck when it said the sums? What were the only series that we said we were able to find the sums of? Geo and telescoping. Is this geo? 2, 3, 4, that's not geo. Is it telescoping? There's no negatives, like nothing is canceled. So how do we find the sum? Wait, the key in the wording is not the sum as in geotelescoping. I'm glad that you thought of those, but wait, as, it doesn't want the sum as in a number. It wants the sum as in, hey, what fully takes this series and says, I'm the same thing on this interval? It wants a function that represents the series, or that is represented by the series. Wait a minute. Why did I have you look at endeavor number 27? Special Maclaurin's. What type of series is this? A power series, but is it a Taylor or a Maclaurin? It's a Maclaurin because it's centered around 0, right? No x plus or minus?
Yeah.
Okay, so I had you look at the special Maclaurins because it is a Maclaurin. Which of those looks the closest to this? A lot of people would think e to the x, and I actually checked my notes from 2 years ago. They thought so too. Let's look at e to the x real quick. What is the special Maclaurin for e to the x? Remember, he is his own derivative? Why am I going to say we should not use e to the x? Anybody tell? Yeah, I don't have factorials. Do you see over 2, over 6, over 24? Do you see the denominator changing at all?
No.
Not a good idea.
1 over 1 minus
What else do you see?
1 over 1 minus
1 over 1 minus x?
I don't know. I mean, I could be wrong.
Abby, don't hurt yourself.
Okay.
I can work with this a lot better than I can
Oh,
work with that.
okay.
Why?
Abby,
This one, I'm stuck with factorials that I have to deal with and get rid of. This one, I get to build from the ground up. Wait, build from the ground up. Hold on. Wait a minute. What else could have been with the x, inside the x, composed in the x, that would get me even closer to what I have?
10.
Ah,
X over 10.
x over 10. Why does that help?
Because it's
Oh.
wow. I feel like this.
Oh, we're so close.
Wait, there's already a
Oh, but I can't bring an n plus 1 into a function of x. That's summation notation. I need to make a function in terms of x, no n. No, what did you say?
Derived.
Why? Is that the derivative of x squared? Is that the derivative of x cubed? Is that the derivative of?
Yes.
Now wait, is that going to perfectly match them? No. So hold on. Can we backtrack for a second? It was looking great until we realized we had to derive. And if we derive, this is going to be 0 plus 110 plus, I mean, we can take a derivative right now if you want. If we take the derivative of this guy, which guys, can we take derivatives of functions? I hope so. We're in CalcBC. But what would we get? We would get 110 plus 2x over 100 plus 3x squared over 1,000. Hold on.
Oh, just stick a 10 on the top.
Ah! Stick a 10 on the top. What do I need to do?
Times 10.
Multiply this whole thing by 10. Because then I would have 1 plus 2x over 10 plus 3x squared over 100 plus, oh, now hold on. We don't quite have the function, but do we have what we need to do to get it? Yes. We need to multiply 10 by the derivative of that guy. Now, to be honest, I don't know about you guys. I don't really know if I want to do the derivative of, I guess we could. I was going to think of rewriting him and making him 10 over 10 minus x, but maybe that would be harder. I guess we could just use the -1 power, right? So the derivative of -1 power, I can bring down the -1, and then I can go ahead and make that squared, and then times u prime. Negative times a negative will be a positive, and then the 10 over the 10 goes ahead and reduces, and then I end up with, do you really think the AP would have that as like a make it match? Now, if it's a long answer, totally fine. Stop it and be done. But how could we rewrite that? No, keep thinking. John's seeing the 10 to the -1, trying to think about what to do with it. Can I just pull out a 110? No, I have a squared. That's totally illegal. Wait, but can I pull out a 100? Yes. And what's 1 over 100?
100. Oh, squared.
Wait, could there have been an easier way of doing this? Not much though. I would think up here. Yeah, because I can write this as 1 minus x quantity squared all over 100. All over 100. Sorry, 10. Did I not put a 10? My bad. I went too fast, I went too fast, I went too fast. Why are we talking about TikTok? If you understand this perfectly, great. If not, the majority of you do not. Oh, okay.
It's 10 bracket -1, and then the number one on the other side makes it a column, so she put it on.
There you go. Thank you. Thank you, thank you. What could have made it maybe just a little bit easier is up here. Joe did notice the derivative, so I just kind of did it in order that we were discovering. But up here, if I were you guys, once you saw the derivative and that it wouldn't have matched, I probably would have gone ahead and tried to multiply by 10 here instead. You'd multiply by 10 here instead. You could have rewritten this to be that whole 10 over 10 minus x to the 1. Then you could have gotten 100 over 10 minus x. And then you could have made it 100 over 10 minus x to the -1, brought down the -1 to -100 over 10 minus x to the -2 times u prime, and you would have landed there. You would have landed there instead of having to like find it yourself a little bit later on. Because then you would have taken the derivative of 100 over 10 minus x. Then bring down the -1, but also multiply by u prime, so positive, and then make it squared. That would have worked also. But do you guys see what I mean by creative?
Yes. No.
Because we had to think about something that kind of matched the powers of x. Then we had to put in something to try to match the powers of 10. And then we had to realize, oh, these are derivatives of x squared and x cubed and x to the 4th. And then we had to offset by a constant in order to make it match. But all of that to say, we were able to go backwards from a power series to a function. The AP loves to throw in those as a part A or part B of an FRQ, or maybe even as a multiple choice. Now, with a multiple choice, I mean, I guess you could take all the possible answers and then just make Taylor or Maclaurin series out of them all. But that would probably take a lot longer than trying to play with and practice the creativity part. But guys, the point of today was not the creativity part, even though I wanted to show you that because it's kind of a cool, like, oh, they could ask us that? The point was actually over here, which led us into that forever endeavor card that you were trying to make yesterday. The endeavor card says, how do we do convergence, intervals of convergence for power series that are not geo? The long story short is, take the n plus first over the nth, but this time in power series, because of the definition of power series, x is raised to successive powers, and even like with sine and cosine, it's a power series, just your x cubed, your x to the fifth, your every other that disappeared was just times 0, but it was there. Power series are going to have these x to the n plus 1s over x to the n's. You're just going to have to consider what else is going on in order to figure out that interval of convergence. So this is the endeavor you were supposed to write down yesterday. We're going to do a couple examples. This homework isn't due until Thursday, though, right?
Yeah.
Okay, cool. So we still can hopefully take maybe the last 10 minutes of class to go peek back at section 10.3 because we didn't get to go over very many questions yesterday. But I did challenge those of you that hadn't graded your homework to go grade it first and come back with questions. But I want to at least get a few examples done because some of you, most of you, all of you need to start. And last I checked, my webcam was working, so oh, it's still working. That's good. So we can even peek at homework if anybody did start it yet.
I haven't done any of this.
Confession time. That was fun. All right, so as you guys are looking at the example, maybe it's too squished. I'm sorry, I just wanted to make it big and then it got all squished. What it's asking is find the nth term for the power series f of x equals e to the x. Then find the radius and interval of convergence for the representative power series. Okay, long story short, we're using. Did they tell us about what they wanted it centered? At or around? Did they tell us? Yeah, I mean, is there anything indicating that we need to make this a Taylor about a particular x?
No.
So then what are we going to say? Okay, let's make it a Maclaurin. They didn't tell us, so let's go about 0. All right, so for doing the representative power series, you guys just talked about who this guy was. It's review, right? He's equal to, why am I using equals and not approximate? Because I'm going to do the series, not the polynomial. 1 plus x plus, he wasn't good a second ago, but he's still a thing. Let's get him down, especially since they're asking for him. Why did I have you write down the nth terms in endeavor number 27? So that you could have them to do the ratio test to if necessary. Well, or if they ask you for the general term, which they didn't specifically in this one, but I'm still going to write it because it might help us out a little bit. X to the n all over n factorial. And why am I using n equal to 0? Because in the Taylor series, this one is x to the 0 and the 0th derivative, aka f of 0. So I'm using it just because that's the first derivative, second, third, fourth. It's much easier to have n equals 0, n equal 1, n equal 2, just like the powers of x. So interval of convergence says ratio test time. And ratio test time says let's go to infinity of the n plus first, which means x to the n plus 1. All over the nth, which means let's flip it and make that reciprocal. Needs to be less than 1. You see why you had to review the ratio test? But the ratio test can be done to any function. It's really nice for taking limits, too. You guys realizing that this is going to go ahead and just give you x, right? N's are all positive numbers. I don't really need the absolute value, but I have, times 1 over n plus 1. Less than 1. Wait a minute, guys. What happens as I go or have n approach infinity? 0. Wait, what's 0 times any x? And how often is 0 less than 1? So why, in your Endeavor card, did it say that e to the x is equal to the Taylor series for all values of x? Because it doesn't matter the values of x. It doesn't matter the values of x. The limit will always be 0, and therefore, this series will always converge. The infinite series will always converge to e to the x. So it's not like that sign where it's like, hey, it's good here. Or I should say it's not like geo where it's like, oh, it's only good for r between -1 and 1. It's like, nope, it's good always, 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 and forever. The infinite series will converge to the exact function of e. Snazzy. Now hold on, wait a minute. So do I just stop and I'm done? This is something about testing endpoints. Wait a minute, do I have any endpoints though? No, but what or where did I have endpoints a second ago? Okay, we just relooked at our Endeavor card. Our Endeavor card says, okay, yes, take the limit, set it less than 1 of the n plus first over the n, and then you get an interval, but then you must test the endpoints when the limit equals 1. Hold on. That doesn't have endpoints. It's for all values of x. The endpoints are what? Negative infinity and infinity? No. But where were their endpoints? This one said only x between 1 and -10 and 10. So hold on. Were we actually done when we boxed it? No, but we thought we were. What we need to ask ourselves is, hold on. What about at 10? And what about at -10? Hold on. The ratio test. The ratio test says it must be less than 1. Pause. What does the ratio test say about at 1? We know nothing. So could it converge? Could it diverge? So what did that Endeavor card tell us, or what is it telling us? We have to check at x equals -10, what's going on, and at x equals 10. Just a word to the wise from the experience that I've had. They could both converge. You have to put or equal to. They could both diverge. You have to leave them both the way it is. Or one could converge and the other not, or vice versa. So pause. Can you guys read to me? Actually, he's that guy right there, right? At -10, if x is equal to -10, what would my series be? N equals 0 to infinity of, wouldn't that be n plus 1 all over, what's -10 to the n over 10 to the n? Isn't it just -1 to the n? What happens if we go the other way, plugging in positive 10? 10 to the n over 10 to the n is 1 to the n. What's 1 to the n? But either way, guys, hold on. Knowing your breadth of knowledge of the parting C, convergence and divergence test, what do we know about what's going on at both -10 and 10 in this example? Why are they both going to diverge? Take the divergence test and you're good. The limit of each of those terms is not equal to 0, so therefore, diverge. So was our answer right? Yes, but will it always be right if we don't test it? No. No. Now, pause. I'm coming to you, Kevin. But first, in our book, remember how I said that 10.4, 10.5 is where they teach all the convergence tests? What context do they teach them in? They teach them in, hey, the ratio test is this guy where the interval of convergence is coming from, and oh, by the way, we have to also test at the endpoints, which means we need to know how to test for convergence or divergence. Let's teach you in like 2 sections. It does a lot all at once. We've already talked about convergence or divergence, so we just get to now apply it to testing the endpoints and knowing exactly the interval of convergence, not just the in-between, but also whether or not we can include the endpoints.
So like if it does converge, what do you have to do?
We would have to go up and throw an or equal to on it. Because this is the interval of convergence. If it converged here and diverged there. Think like alternating series. Okay, it'd be more likely to converge here in this example because of the alternator. Let's say it did, we just throw an or equal to, or we would make it a closed bracket and a parenthesis. Is that cool? So we have our endeavor card. We just saw that whole must test the endpoints thing. It's up to you guys as to whether you think you need more of a reminder. How do we test the endpoints? I mean, you can put parting C. The main idea is you got to plug in the endpoint. Oops, I can't spell parting C. So, I was doing a particle motion. Anyway, parting C. We have to plug in the endpoints, and then we have to do the convergence divergence test like chapter 9 and 10. The nice thing is we separated it though, so that we don't have to be learning all of that right now in the midst of the end of a pretty complicated chapter. And all of that was because the ratio test says, hey, when the limit is 1, we know nothing, so we have to try something else. Exactly, we're trying something else at each of the endpoints. And we have to show that analysis if they ever ask us for an interval of convergence of a non-geo series, in like an FRQ. There is this extra guy down here, the radius of convergence. Let's talk about him real fast. Radius, half. That's easy. Half what? Half the interval. So guys, what's the interval of this one? How long is that interval of x's? Infinity. So what's the radius of convergence? Infinite. Yeah, so the radius of convergence, I can spell radius. Is just infinity. So we have our IOC, then we have our radius just being infinity. However, the one that we had just a second ago, wait, what does radius of convergence mean? Start at the center, start at 0, start where your power series is about. And then, how far can I move both ways and still have it converge? Forever and forever? Perfect. But pause, how about this guy? If I was to start in his center, which is still, again, it's a Maclaurin, so center is 0, how far could I move right and left and have it still converge? 5. Why? Well, because the distance is not 5. The distance from -10 to 10 is 20, right? So, from the center, how far can I move? 10 to 10. Radius of convergence 10. You do not have to worry about the endpoints as to how you make that distance. You do not have to worry about the endpoints as to how you make that distance. You take the distance from the beginning and the end of the interval, cut it in half, and you just go ahead and name that R. If you want to think about it, if it's not including the endpoints, that is an infinitesimally thin, a one-dimensional piece of space. So it doesn't take up any, I'm just going to use space again. I don't like using that, but it doesn't take up any space, therefore this radius doesn't change just because the endpoint is missing. If you guys track with that, cool. If you don't, no stress. Just take the beginning, the end, subtract, and divide. Okay, so if I was to zoom in, we'll end here today. Beep, beep. Yep, I want you guys to play with interval of convergences and radiuses of convergence. And as you guys do that, is there anything in particular you want me to look at as far as 10.3 questions that remain? So I can get it set up on our webcam. Any 10.3 homework questions that you know off the top of your head? Can we look at this?
33.
Okay. Got it. 42. Ooh, nice. That has to do with convergence too. And you said B, right, Jacob?
Yeah.
Okay. Making sure I had the right one. People who are on the video, just go ahead and go back and pause on the problem they're working on. I'm just getting homework questions ready. And Gavin. All the above. They're sending good wishes. Dean will see it today. Gavin probably tonight or tomorrow. ¿Dónde está?
Bring me some Chick-fil-A tomorrow.
-1 to n plus
I'm
b.
kidding.
Oh, right. That's ratio, isn't it?
I don't know what that is. Oh my god.
It's not the limit, it's the series, right? Oh.
Alright, do you guys have both of them written down that you can be playing with them?
Oh, both of them.
I'm going to go talk about those 2 homework questions, but I want you guys to be able to be playing with these guys and seeing how the interval of convergence and radius of convergence, how they're going. Don't forget to test the endpoints. Dean and Gavin, if you don't need those homework questions, go ahead and pause the video now, and you can be playing with these 2 like the rest of the class. All right. Bloop, 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 bloop. Homework questions. I have 2 of them. I'm going to play with both of them and see how we do. If you need it, cool. Pay attention. If not, all right. Go play with radius of an interval of. Oh, start with interval, then go to radius. It's kind of awkward. They ask it the other direction. Start with interval, go to radius. Okay. So number 33b. First off, we have this original function up here, 2x over 1 plus x squared. It looks a bit like a geoseries. And so I'm going to go ahead and look at this as a geoseries real fast because I can think about 2x as being my a sub 1 over 1 minus r. 2x can be my a1 over 1 minus negative x squared. So I can think of this as a geoseries with my first term being 2x and my r being negative x squared. And so you already got A done. The question was on B. Does the series found in part A, when evaluated at 1, converge to f of 1? Explain why or why not. They're asking me whether or not convergence will be occurring at 1. Well, to do that, I would have just thought about geoseries. Hey, it's before that whole ratio test thing. I just know my common ratio has to be less than 1. Absolute value makes it a positive, no big deal, less than 1. Now has me thinking about plus or minus square roots, which actually leads me to x needing to be between negative 1 to 1. The crazy thing about geoseries, though, Jacob, is that it cannot be at or equal to 1 or negative 1, meaning the ratio. So even though everywhere in between is good, at 1 itself, convergence will not be held. At 1, this series will diverge. At negative 1, this series will diverge because it's not within the geo ratio of convergence, interval of convergence. So therefore, my explanation would be no, since the interval of convergence for this geometric series is, I wouldn't say R, I would actually put in the x in which you solve for. X is within negative 1 to 1, not including. In this specific example, 1's not included. Does that make sense? All because of that less than. And then notice over here in the multiple choice, we have the Maclaurin for cosine, which they wrote out, but we already know that kind of, or should be memorizing it. They want the smallest value of n. This is like the one that Lorenzo and Joe both kind of practiced yesterday a little bit. For all x in the interval negative pi to pi. For this one, since it's an alternating, I'm going to be thinking of the alternating series remainder, just so you guys realize what I'm thinking. And I'm going to be looking at the x to the 2n all over 2n factorial. Don't need to be worried about the negative 1 because I'm thinking of absolute value. And when this is less than 0.01, if you look at the top of the page, it actually says that calculator is allowed. So I literally went ahead and put this into my, nope, not my calculator yet. I thought thought next about if I needed to be safer rather than sorry, I need to choose the largest possible value of x to make sure I have a proper error bound. So I need to make sure that the error is for the entire interval. So I went ahead and thought about, okay, this x is going to be maximized on pi. So I went ahead and plugged in pi, saying, okay, wait a minute, that's the highest. I need to make sure I account for all of those x's, including the highest. Then I went ahead and plugged this into my y1, and I went looking into my table at things like 2 and 4 and 6 and 8. And here's what I figured out was x to the, or I should say pi to the 12th, all over 12 factorial, is the first time that it was less than 0.01. Lorenzo helped me out just a little bit because I was kind of getting stuck on, hey, this occurs when n equals 6. But the problem is that's the n for the alternating series. That's not the n for the power series. Technically, the power series, this is the 12th degree power series. And so if the 12th degree is less than 0.01, remember alternating series is, think about this as n plus 1. In the sense of it's one beyond the actual, and so I could approximate with, thinking power series, this is the 12th degree, I could approximate with the 10th degree. Because I could use the 10th degree Taylor polynomial, the 12th degree, which would be the next term, would be less than 0.01, and everything would work out. Does that kind of make sense? It was when n equals 6, which was confusing. But we were thinking about the Taylor polynomial, that's the 12th, go back 1 to 10. And then I have it. I don't know if that was necessarily the most detailed explanation, but for the time that we had, that at least got the idea across. You guys were going ahead and playing with these ones that were over here. Was that the first example? I have up here, I hope, I was going to try to show it to you. The answers, if I have it correct. Aha! Is this the right one that you guys were doing? Please tell me yes. We were doing view, we were doing page display, single page view. Your final answer on the left should have been open interval from 3 to 7, closed interval with a radius of 2 because the distance is 4 cut in half. And then this one should have been between -3 to 3, both open because both endpoints diverge with a radius of 6 divided by 2, which is 50. Maybe you finished it, maybe you didn't, but now it is on the video for you guys to come back and look at. If for any reason you get stuck in homework and you aren't able to keep going, you can come check out this example of how I set up the ratio test, less than 1. I went ahead and took the limit. These ones, degrees were tied. I had to go ahead and solve for x using the idea of absolute value. I got my interval, but I had to think, wait a minute, what's going on at 3? And go parting see it. What's going on at 7? Parting see it. That guy converged based on, I think, the alternating series test. This one can diverge because of, the limit was infinity? Oh, no. The negative got pulled out. It was a simple harmonic P series. P is equal to 1. That diverged. So I had to keep it open here, but I was able to close it there. This one over here, same idea, how I set up the ratio test, how I simplified, how I got x between -3 to 3, and how I plugged in and saw divergence. Anyway, tomorrow we're going to do more examples. That's why that homework isn't due on Thursday, but I would definitely start it. Let me pause the video, and then Lorenzo, let me see what